Good evening, my dear friends and my dear students. So, good evening, Shubham, Akshadeep, Tamanna Sharma, Dhruv, Shamanika. Okay, today we will be talking about introduction to metallurgy. So, before getting into actual topic, so we will recap the last class what we had done. So, I completed colloids. So, surface chemistry second part. So, we discussed about applications of colloids in the last class. So, there are various applications like Tyndall effect, okay, Brownian movement. We discussed about applications like how purification of water, delta region, quadrilateral precipitator and other things. So, today we will be talking about the metallurgy. So, you know that in any engineering applications we require a metal, okay. So, that is why this plays a very important role on engineering sciences, okay. So, not only engineering sciences, when we talk about the metals play a very important role in terms of minerals in the body of humans. So, that is also very important. The zinc, iron which is there in the hemoglobin and another enzyme, that is what we call as coenzymes. So, they play a very important role. That is the reason we will be talking about the extraction of the pure metal by using a branch of science which is called as the metallurgy. Okay. So, before getting into actual topic, let me talk about the CCP question. The CPP question which went wrong majority of the students, which was I have done in the my last colloidal class. The question goes like this: the purple gaseous of a colloidal solution, okay. So, the purple color of the colloidal solution, this is what I discussed about in the application of gold. So, when you take the gold particle, when you go for nanoparticle size of different sizes from 10 to 50 nanometers, so you find the application or the color of the gold will turns to purple. So, as you see, the gold in the macro state is a yellow in color. When it becomes a fine particle less than 1 nanometer in size, it becomes black in color. But the size, if it varies from 10 nanometer to 15 nanometer, then the color of the gold will be purple in color. So, that is the reason this question was given based on the application of colloids. It is a fact. So, unless you remember this, you cannot answer this. That is the reason I told in my last class also. So, in order to answer this question, you have to go through the videos, okay. So, now today's class, I hope you understood this. So, as the size of the particle varies, the color of the material also varies, because the colloidal particles depends on the size. So, based on that, so this will be the purple color is the gold is the answer for that. So, for today's class, the goals goes like this. Our objective of the today's class is the occurrence of elements we will be talking about, and what is the concentration of ore, how we are going to extract these metals, that is called as isolation. Then what are the different methods which involves in order to extract these metals from the respective ores which we obtain from minerals. So, then finally we talk about the refining of metals. So, in this class I will not be talking about the extraction of metal as such as an impure conditions. So, I will be talking about different techniques and the methods which involves in metallurgy. The first thing we have to think of how actually the occurrence of metal takes place in the earth crust, because the major elements which we extract, they are all obtained from the earth. So, that means when you look at the majority of the elements, when we talk about the oxygen, okay, which you are seeing over here in the pie diagram, which is the most abundant element, okay, which is in the gaseous state. When it comes to a solid, the next element which you find out is the aluminum, which is roughly about 8.1%. Then the next element is comes about the calcium, next is potassium, next is iron which is about 5%, next is sodium about 2.8% and the magnesium. So, this potassium, sodium and magnesium especially present in the oceanic water, because that is the reason. So, we get all of them are highly reactive, that means they exist in the form of their chlorides rather than the oxides, carbonates or sulfates. When it comes to iron, it exists in the form of oxide, calcium exists basically in the form of carbonates, whereas aluminum exists as once again oxides, okay. So, now when you look at the majority of the element present in the nature is oxygen, the second most abundant element is the aluminum. Once we know the occurrence of these elements, so they exist in the combined form, they never exist in the free form. Only the few elements, if you look at what are those elements which exist in the free form, so they are called as the noble elements. I think, can you tell anybody what are the noble elements which are in the periodic table? because the periodic table you might have already studied in the first PUC, where we classify the metals, non-metals, okay, reactive metals and as well as the gases. Along with that, a special 3 elements in the periodic table are called as noble elements, and this is the most favorite for especially women's, the 3 elements which we are talking about. One is the gold, the yellow metal, next is the platinum, which is the silvery white metal, next is the silver itself, it is a very shiny metal. Okay. So, when we talk about these 3 elements, they play a very important role when it comes to investment. I am not talking about the chemistry of that when it comes to investment, but they never get into oxidation state. That is the reason they get a special value, that is why they are called as noble. They never undergo oxidation in their lifetime. Okay. So, that is why then they are least reactive. When we look at the electrochemical series, they get the positive electrode potentials. So, that is the reason they are very difficult to oxidize them. So, hence those elements are called as noble elements. I think majority of the group people are some of the students are talking about group 18 elements. Group 18 elements are called as noble gases, not the noble elements. I think Archie has answered group 18 elements. Please correct yourself. The group 18 is only for noble gases. Okay, it is not the elements I am talking about. Okay, today we will be talking about extraction of elements. Okay, so that is the reason you have to be little careful. They are called as gases, noble gases. They are also called as chemically inert and they are also noble because of their completely octet nature. They are not going to show any reactivity. Please make a correction that group 18 elements are noble gases. They are not noble elements. The noble elements are only, okay, are metals which you consider platinum, gold and silver. Okay. Yes, I think you got it. Yes. Now we will be talking about what all this and where you get these substances. You all of you know this. These substances are compounds which we are talking about. They exist along with the rocky material, okay, or silicates or carbonates. Hence, they are called as the minerals. The minerals are the natural substances, okay, from which a metal can be extracted, but it is a tedious process. That is the reason we are not going to use the minerals as such. If I use a mineral, okay, so it contains so many earthy impurities. So, that is what in metallurgy we call that substances, unwanted impurities are called as gangue, or it is also called as the matrix. I will be talking about that later. So, now when coming to the minerals, there are so many minerals exist. Now, if I want to talk about iron as an example, if I want to extract iron, so if you look at, there are 2 minerals exist. One is the Fe2O3 and another is Fe3O4. These 2 are called as minerals. From both we can extract iron, but we go for the first one, Fe2O3, that is called as hematite, because from which an element can be extracted economically and with a higher yield. That is where that substances are called as the ores. That is the reason one slogan goes, all of you know that, all white things are not milk, but milk is white. Similarly, when we talk about ore is also like that. All ores are minerals, but all minerals are not ores. So, this is what you have to remember here. Okay. So, when we are talking, so this when we take Fe2O3, that is called as magnesite, from which iron can be extracted in a better way. That is what you might have heard of, especially in India, we find 2 places. One is Kudremukh, okay, so which finds, and another is a Ballari iron ore. So, if I use a magnesite, okay, so that magnesite and hematite both exist, but if I use the first one, okay, hematite, you are able to get around 65% of iron. If I use 1 ton of iron ore, so we are able to get about 65%, that means 35% is only wastage. But if I use Fe3O4, that is magnesite, so you are able to get around 35 to 45% of iron. That means you are spending lot of energy as well as the amount on that to get a less quantity of it. That is the reason a ore is always which gives a effective metal from which we are going to extract. So, that substances are always called as ore. They are also natural substances, but they contain less of impurities. Next, when we talk about the metallurgy. So this metallurgy is nothing but it is a branch of science. If I want to talk about this in little detail, this metallurgy was only studied by the two people in the earlier days. That means I am talking about 15th, 16th centuries, only two people. That is why they are called as jobless people. Who are there? One is chemist and another is metallurgist. Because there was no much industrialization was there. So that is the reason they were not able to use the metal as we are using in 21st century. That is the reason what the metallurgist used to do, he used to extract a metal and he used to give it to a chemist. What chemist used to do? He used to take this metal and try to make a reaction with some acids, some bases, and he used to study what is their chemical physical properties and he used to record the data. But till the industrial revolution took place, there was no metallurgical applications has been used. Once after the Second World War, the industrial revolution has took place, then this metallurgy was studied by each and every scientist and each and every engineer, because today what all the materials we are talking about, they are all made from metals or from non-metals. Hence the entire polymer science today which we are talking about, non-metals from carbon compounds, which is the ruling the entire world. Without plastic nobody survives today, because plastic in the sense I am talking about your polymers I am talking about, okay. The day begins with the polymer and the day ends with the polymer, because if you think of when you get up in the morning, you look for always a bristle, which is the brush which is made from a nylon. The moment you go in the night for a bed, which is also Kurlan, which is also once again a polymer. That means the entire day activity is purely depends upon this branch of science. So now like this, when I talk about metals also, each and every engineering aspects today will be using this metal in one or the other form. Thereby the metallurgy has taken a huge boom, and apart from that the chemists are also having a huge role in them, because they are going to make materials of required properties. So this is where we are going to make use of the mixing of one or two metals or more than metals. That is where we get a substance which are called as alloys. The best example I can give you is copper and zinc, soldering lead, like that n numbers we can talk about. The next is the gangue, which is not important to any person who talks about metallurgy, because this is the waste material which is associated with the ore or the mineral. Because of that the value of the ore comes down, okay. So now we want to remove this. If we want to remove this, so it investment for the extraction of metal goes up, hence the costliest, what is the cost of the metal is also becomes higher. So now how actually we are going to make use of these properties for extraction of metals, we will look in. I hope you are all getting the things. Now in order to extract these metals from the respective ores or from the minerals, so it is not directly by a magic wonder like a Harry Potter stick. So it has to go with certain techniques. So that is where we will be talking about the first process, in which it goes with the crushing and grinding of the ore, because so you get majority of the minerals or the ores in the form of lumps are called as nuggets, okay, NUGGETES, okay. So these are large lumps usually and large inner size. So this will be mined from the earth crust and will be sent for process called as pulverization. The process of making a larger molecule, that is bigger articles, a rocky material into fine powder, it is called as pulverization. So this is the first step it goes. Once this is done, then we go for two more methods. So that is where it depends upon what type of impurity is present. That is where we talk about the concentration of ore. The concentration of ore means it is not similar to your normality or molarity I am talking about. Increasing the content of the metal in the given mineral. So this is called as the concentration of ore, because the minerals are n type, but from which we cannot extract a metal. Thereby we require a suitable ore. So what we do? We convert the mineral into ore. So that is where we require a different techniques. The first is called as hydraulic washing, or this is also called as levitation method. I will be talking on that in a few minutes later. So the next is the magnetic separation. Next goes with the froth flotation. So this is the first three are very important, and may not be employed in all the techniques of extraction. It depends upon what type of ore you are using for extraction or concentration. So, based on that, the first three will be used. The last one is very specifically it is used for a particular ores. So, this we will discuss in it. Next, once we concentrate the ore for enriching of the metal, then we go for isolation of metal from the concentrated ore, because so this will avoid the majority of the investment of energy onto the system. So, that is why, so this will be the third step. Once we obtain the crude metal, so the moment if I say isolation, we are not able to get 100% pure metal, you will be getting a crude metal which goes from 95% to 98% purity. But if you want to make an article, so always we look for 100% or 99.99% purity of the metal. Hence, so we go for the finally refining of that crude metal to get a refined ultra pure metal which can be used for lots of applications. Okay, I hope you understood. These are the 4 methods or the techniques which are employed in any of metallurgical process. Okay. Now, once again I define what is metallurgy. Metallurgy is nothing but art and science of extraction of a metal from a suitable ore. I repeat it once again, metallurgy is a process in which it is an art and science of extraction of a metal from its respective or suitable ore, okay, economically and beneficially. So, that is what is very, very important. I should not invest more, but I should get maximum pure metal from that process. So, that branch is called as metallurgical process. Now, we will be talking about the individual process which goes over here. Okay. So, this is where I will be talking about hydraulic washing, or this is also called as gravity separation, or this is also sometimes used as levitation process. Okay. So, in which what we do is the basic principle of this hydraulic washing. So, the name itself talks about hydraulic, that means there is an involvement of water, this is most important, and the impurities and the ore particles we differentiate with respect to a particular pattern or the property. What is that? That is called as densities. It is like this. Okay. I think you watch sometimes comedy shows, okay, where we talk about a tin and pat. Okay. So, tin and pat means one is fat fellow and another is thin fellow. If you make them to run, so who runs first? So, like that, if they have a different densities, so then we can make their separation easily. This is a little simple concept was been used in separating the ore with the impurities or the matrix or the gangue particle. Okay. Similarly, yes, Ganesh is talking about Lorry and Hardy also. Yes, that is also fine. Okay. So, Lorry and Hardy are from US, this tin and pat from German. Okay. So, those are that is also fine. Lorry and Hardy also you can take an example, because one is thin and one is a fat. Okay. So, that is where the densities plays a very important role. Now, what actually happens in hydraulic washing? Okay. The pulverized ore from the first step will be taken over into what we call as levitation table, in which the table is slanted at an angle of 45 degrees. Okay. So, which contains a grooves in between, and this is kept on a vibrating platform. Okay. So, there is a vibrating platform will be there. Now, on the top we are going to use a funnel kind of thing, where you are going to feed water plus pulverized ore. Okay. Now what happens? So, there if I want to use this method, you have to remember there should be a density differences. What is the density difference between each? So, that means the ore may have higher density, or the gangue may have higher density. If both are having higher densities, we cannot use, or comparable densities also we cannot use this method. One should have higher value and one should have lower value. That means the difference in densities between the ore and the gangue is made use in this process. Now, the moment when we make a slurry of this and it is allowed to pass through this waffle vibrating table, the heavier particles, okay, settled in the groove, and lighter particles which flow from the table, and they will be collected on a separate heap. Hence, we are able to collect the ore particles in the grooves, whereas the gangue particles will be collected in the bottom, because there is a continuous stream of water will be flowing through this, which makes the ore and the gangue completely separated. Okay. So, this washing is called as hydraulic washing. So, 90% of the ores will be subjected for this process, because majority of them contains either silicate, SiO2, or it may contain rocky impurities. In order to remove this, not only rocky impurities, sometimes clay also associated with this material. That is the reason all these are highly soluble in water, and once they get hydrated, they become heavier in nature, thereby the metal become lighter and this gangue becomes wetted, hence becomes density wise higher, thereby they can be easily separated. The next step is goes for magnetic separation technique. So, this is once again very clearly talks about. Yes, Dhruv, it is correct, the difference in density, so that the heavier stay while lighter flows through water. So, that is what is talked about here. Okay. So, the next step which we go for is the magnetic separation. So, example if I want to give is FeWO3. So, this is iron tungstate which we call it as. Okay. So, this is a one of the ore which is supplied or what we call as employed for the magnetic separation technique. The reason behind this is, as the name itself indicates, this method is applicable only when either your ore, okay, or your gangue, any one should be magnetic and other should be non-magnetic. If ore is magnetic, this should not be magnetic. If this is magnetic, this should not be magnetic. That is where you have to consider. If both are magnetic, hence we cannot separate them, because both will stick to the process, hence we cannot separate them. So, make sure that any one of the ore or the gangue should be magnetic and other should be non-magnetic, hence we can employ this. In this case, if I give a tungstate ore, okay, iron tungstate, in this iron is magnetic in nature, whereas tungstic oxide which is non-magnetic, hence we can employ for separation of tungstate from iron by using this process. A very simple technique once again, the pulverized ore is subject to hydraulic washing, then it is dried. So, that concentrated ore is subjected for magnetic separation. So, here it goes like this, we have a rolling belt, okay. So, one of the roller is converted into magnetic nature by applying electric field, electromagnetic by induction process, okay. So, here we are going to take the concentrated ore to this. So, we are going to add this powder form of this ore, that is iron tungstate, after hydraulic washing and drying. So, that comes over here. So, here the first roller which you are seeing is non-magnetic in nature, whereas the second roller which is applied to electric field, hence we are going to have a magnetic property over here. Once this ore and the gangue passes through this, okay. So, here the magnetic material will stick onto the belt, which is the rolling belt which is kept over here, whereas the non-magnetic component which is here tungstate over here, so that will be collected over here. Because it is non-magnetic, once it goes out of the magnetic field, it is thrown away, thereby it collects as a separate heap. Similarly, the magnetic material which is attached to the belt, still the magnetic field, it will be sticking onto this belt. Once the magnetic field goes off, automatically they collect in the other end of the process. So, this is called as non-magnetic material. So, now you can see very clearly the first which is thrown out, it is non-magnetic, okay. So, which is collected over here, and the non-magnetic will be collected over here. So, that means it will have two separate heaps, thereby we are able to separate the ore as well as what we call as the gangue particle by using magnetic. So, only thing is the difference in the magnetic properties is the principle of magnetic separation process, only where iron is involved. Not only iron, if you look that there are so many other metals also show the magnetic property. It depends upon, I think Ganesh is asking this question, only iron can be used. No, it is not like that. We can use for other things also, like magnetite, chromite, as somebody is Tamanna is answering for that also. Where all you find a metal, if it exhibits the free electrons, so as per Bohr magneton, I think you might have studied Bm, which is nothing but Bohr magneton, where we consider n into n plus 2, where n acts for number of lone pair of electron or number of unpaired electrons. If that is there in the case of that metal, then you can get the magnetic momentum for that. So those elements also can be taken into this. Okay. So that's why the number of unpaired elements which exhibits, so those will act as a magnetic. In that condition, we can use this. Not only with iron, which all the elements will exhibit unpaired electrons, they exhibit Bohr magneton, then we can employ. Make sure that your ore and the gangue should be different in their magnetic property, then only. I think Ganesh is clear. Yes, I hope. Okay. So next is the froth flotation technique. So this is very, very important. This is only employed. Now, I think you remember the froth flotation technique is employed only when the sulfide ores are there. So this is very, very important. This method is not employed for any other process except sulfide ores. So that is ZNS, galena, this is okay, PBS if I am talking about. Okay. So these kind of ores which exhibit sulfur in their compounds, because these are chalcogen compounds, because they comes under the category of your carbon and its compound, because majority of your ores exhibits in the form of carbonates or sulfides. Hence, so these sulfide ores are only extracted by using the froth flotation technique. Okay. So this, if you want to employ into this, if you have a metal, if it is magnetic, then you go for magnetic separation, or directly you can come down to this froth flotation after hydraulic process, because we can avoid magnetic process, because none of the zinc or lead are magnetic in nature. Hence, we can directly enter after hydraulic process to froth flotation process. What actually here happens? So this is what we called as the differential wetting takes place. Differential wetting. What is this wetting process? It is like this, very simple technique. Okay. If you don't want your hand or your face to get with water absorption, so what you do, you apply a Vaseline. Similarly here also, we use certain agents or an oil which will wet either gangue or the metal, so that they become hydrophobic in nature. Once they become hydrophobic, their weight becomes lesser, where the molecule other than the metal or the ore, if it gets hydrated, they become heavier in nature, they settle down. Then we do agitation by adding certain material which is called as a detergent, they create a froth. That froth, what it does, it carries the lighter particles to the surface. From there we skim off that material and we add antidepressants, and then when we get the metal in the pure form, which is away from the impurities. So this is what actually happens in froth flotation technique. Now how it will happen, let me explain by using a diagram. So this will be used tanks. Okay. So it is separated like this. So here we are going to add the ore particles, which is pulverized, and it is treated with hydraulic process, which contains sulfide ores here. For this we add a special oil called as pine oil. The moment you add a pine oil, the metal which is present in the ore get hydrated. That means, sorry, not hydrated, it gets wetted by oil, and that means it is the surface of this metal is completely covered by a special layer which I am talking about here, like this. So you can see the particle completely gets covered with oil. So metal is inside, but it is surrounded by oil particle, thereby it completely become hydrophobic in nature, it never interacts with water. Now what we do, we add a water to this. The moment you add a water, the gangue particles which were there in this ore get wetted, that means as similar to this. So now assume the gangue particles here may be of green color, which is rocky material which was there. So, now this material will be completely surrounded by or covered by your water, which is yellow in nature. So, now you see the black is particle over here, the ore particle which is surrounded by oil layer. Similarly, the ore particle, that is gangue particles, is completely surrounded by your water, thereby this becomes hydrophilic. This becomes hydrophobic. Water hating nature, hence they get separated by themselves because there is a heterogeneity starts. Once heterogeneity starts, we use an agitator and air is supplied. Because of that, the froth is going to come. The froth comes because of we are adding a special agent called as sodium potassium xanthate. Sodium potassium xanthate. So, this will give us a froth. Because of this, the froth will carry the hydrophobic material to the surface. Your ore particles will come to the surface and that will be mechanically skimmed into the next chamber. Then we add water here, then we remove the froth and you can see the ore particles are comes over here and all the heavier particle which are hydrophobic in nature, they will be collected in this in this tank. So, thereby we are able to separate your sulphide ore from with respect to metal. Okay. So, now before getting into the next process, so we will move on towards today's contest time. Before that today's contest, so I would like to look for the previous contest question. So, this is what the previous contest question: how many sigma bond and pi bonds are present in the total in the given organic compound. Okay. So, if you look at over here, the answer which was done from your side is, and the winner goes to Deepak. Deepak will get 1 atom session to his account. Okay. The today's contest question, we are all waiting for that, goes like this. So, it is based on today's topic. The metals occurring in the form of their compounds in the earth crust are called matter, minerals, alloys or gangue. I repeat the question and you can see on your screen also, the metals occurring in the form of their compounds in the earth crust are called as matter, minerals, alloys or gangue. I hope you all done this with this today's contest. Okay. Now, we will move on towards the extraction of metal from the concentrated ore. So, now we have separated the unwanted material, that is a matrix which is present along with the ore. So, now in order to get the concentrated metal, we go for the two process. One is called as conversion of the concentrated ore to its oxide form, that is by oxidation process. So, this is very important. In this we use two techniques, one is called as the calcination technique and other is called as the roasting process. Okay. In the second process, once we convert the conversion of oxide into metal, so that is where we are getting into reduction. So, that means purely electrochemistry plays an important role in extraction of any metal from its ore, because they are always exist in the form of combined ore. So, now if I want to break that, definitely I have to use oxidation followed by reduction. So, that is what the technique which we use. That is why any metallurgist should be first a good chemist, then only he can become a good metallurgist, because he should understand what is the chemical property of that ore, then how to extract that metal in the pure form. It is purely works with respect to the chemical aspects. So that is where, so we are talking about the calcination, the roasting first. So coming to the calcination, so here when we talk about calcination, it is a process. Now you can see it will be done by using a special operator called as the reverberatory furnace. Okay. So here we are not talking about a simple techniques, these are all huge and a very large equipments. Okay. So here they are called as furnaces. Furnaces especially called when the temperature goes very high, that means more than 800 degrees if we are using, so then we call them as furnaces. Okay. So that is the reason here we called as reverberatory furnace. Now if you see here, the ore is kept over here and we use the heating element like coke or any other source of energy on the other end. We are not heating that ore directly here, the heat will be transferred in the form of radiation to the ore. Okay. It is like this, in winter when you get cold, you are not putting your hand into the flame, we are just sitting next to the flame and we are moving our hand physically. Okay. Like that here also the heat radiations are made to, okay, touch or fall on the surface of the ore material, which is called as the earth, not EARTH, this is called as HEARTH, earth. So where the volatile impurities are removed from the ore and where we get the concentrated ore. Okay. The calcination is a process in which the element or the ore which we want to concentrate will be heated indirectly and with less oxygen concentration or limited oxygen concentration, in which all the volatile impurities gets converted, evaporates, and if material contains some oxides, okay, or sulfides, they will convert into especially sulfur dioxide or carbon dioxide will get in, thereby we are converting the element into respective oxides also, that is the one important, and completely moisture is removed in this process. So that is why this is called as the calcination. Calcination is a process in which the ore is heated below its melting point in limited or what we call as less supply of oxygen indirectly, that process is called as calcination. Next we will be talking about roasting. I think this all of you know. Okay. So we want, when we go to any hotel, we want a masala dosa, we ask them to make roast because it will become somewhat tasty. Similarly here also, if I want to get the dry and pulverized oxide of metal, so we go for a process called as roasting. So here what we do is any metal, okay, with if it is sulfide, if it is there, so when I go for roasting, so that is where we add oxygen in excess. Remember here we are going to make the ore to come in contact with excess of oxygen, and once again it is heated below its melting point. Okay, the melting point of the ore we consider, and below its melting point we heat this. So thereby this metal which is having a sulfide ore or some other ore will get converted into Fe2O3, then it gives rise to SO2, sulfur dioxide goes off, or it can be sulfur trioxide or what we called as SOX. Any oxides of sulfur gets over and you are going to get the Fe2O3. The next process, as I already said, this is first is oxidation process. The next process we will be talking about the reduction, that is removal of oxygen. Then what will happen? You get the iron. This will be impure iron. Then I am going to purify this to get 99.99% by using purification technique. That means we are in the second step where we are converting unwanted product into the required product from which a metal can be extracted effectively or beneficially. Okay. So this is one of the things which we are talking. So next is, instead of iron oxide we can use the lead oxide also, PBS, galena. This is called as, when it is treated with this, you are going to get Pb plus SO2. Here also you can see the lead will form, or sometimes you are going to get lead oxide, okay, PbO2. So this is highly unstable. Then we go for reduction and then we can extract the metal from this process. So that is why roasting. Roasting is a process in which the metal is heated in excess of oxygen along with more of oxygen below its melting point. Okay, Arush, I can't understand roasting. Yes, I will repeat the things. I will repeat the things. Sorry, I didn't see that. Let me answer your question. Okay, roasting. I think have you tasted masala dosa or have you tasted pup in a bakery? Okay, whenever you go there, you ask them for roasted. That means eating. So that is what we did in the calcination process. Eating is calcination. Roasting, what we do is we are going to make a oxide of any metal. Suppose lead oxide is there. So that will be treated with excess of oxygen. O2 will be given in excess. Then what happens? So when we eat this to below its melting point, the melting point of lead sulfide, okay, because the moment it goes more than the melting point, it becomes molten state, then it will be forming complicated oxides or carbonates or any of the compounds. Hence what we do in this process is we take the ore, treat with excess of oxygen below its melting point, then it will convert into respective oxide, okay, along with the sulfur dioxide or unwanted gas will liberate. The roast is the word which is used for giving the most of oxygen and converting them into respective oxide. That is where we called as roasting. So if you keep roasting the things, just let me give an example, simple one. Suppose you are making a chapati at house, you forgot to replace the other side, what will happen? It will get roasted. That's why it becomes charred. So similarly here also what we are doing, we are taking the ore and giving oxygen. There also in chapati air is there. Automatically what happens? You are giving from heat from the bottom, then it takes excess and it will become charred. Similarly here also the oxides will be formed. So that will give us, it removes completely moisture during the process of roasting and it expels unwanted oxides, sulfides, carbide, that is carbonates. Thereby your ore, that is what I am talking about, concentrated, will become more in the metal. Suppose if I take this, this will become rich in metal. So that is why the roasting process is done in order to get the pulverized amorphous nature of the ore we have to get. That is the reason the roasting is done. I hope Arush, you understood what I am talking about roasting. Roasting is a process in which the ore is treated with excess of oxygen below its melting point, okay. So then they will convert into respective oxides, okay. So this is all about the technique which we are called out roasting. The next is the reduction, because first step is over, then we want to go for reduction. This is where we talk about the smelting. Smelting is very important process in metallurgy once again. So what is the role of this smelting? This, in this process, the extraction of metal in the fused state, that is where we called as smelting. What is this fused state? When we called as a fuse, so this is also called as when a metal is converted into molten state without using aqueous nature. That means we are not adding water to that, but we are getting in the liquid form. So that is called as the molten state or the fused state. The majority of the metals will be extracted in this fused state, because if they are reactive, so we have to go for this, otherwise they will convert into the oxides once again back. So here what we basically do is we do a reduction process. That means imagine, so I am going to have Fe2O3, because you all of you know this is the ore. So when it is treated with the coke, which is a reducing agent, okay, at a very high temperature, maybe around 1200 degrees centigrade, okay, in absence of oxygen. So then this will get converted into iron plus 3 molecule of carbon monoxide. So this is very important, okay, reduction with carbon and oxides of carbon. We can use carbon dioxide or we can use carbon, because, so I will be talking about a process which is called as Ellingham diagram. So in which, so I will be talking about why only carbon and certain metals has to be used as a reducing agent, okay. So now what it happens over here, you can see carefully here, reduction I am doing. Reduction means removal of oxygen. So which makes the metal to be in the crude form, not the pure form, it gets into crude form. This will be about 98% purity and some impurities will be there. So that we have to remove by using another process called as refining of the metal. Okay. So this is where the smelting process goes. I hope all of you understood. Sir, some student is asking about some of the textbooks. See, I will tell you, the textbook name does not matter, the concept given in the textbook matters. Which textbook you use, that does not matter. Okay. So how the concept you understand, that is matters. That's the reason I am not able to tell you which book is good. If you understand the concept from any book, definitely it is good. Okay. So next we will go for hydrogen reduction process. In hydrogen reduction process, especially we go with tungstic oxide WO3 when it is treated with molecular hydrogen. It is not nascent hydrogen, because in the case of reduction we use both kind of things. When I am doing a organic chemistry, that is where we will be talking about the nascent hydrogen. So when we are talking about reduction process here, molecular hydrogen will be used. Okay. So when we use this, so upon heating here, so you are going to get the tungsten along with moisture comes out. This moisture, it is not in the liquid form, it is in the steam form, because the temperature which we are giving over here, it is very high, about 800 degrees centigrade. You know that we are going to get dry steam. So that will be taken out and you are going to get the crude tungsten from this. Then tungsten will go for purification in the next process. Next is alumino reduction or aluminothermite process, where aluminum is used as the reducing agent. This is once again plays a very important role for chromate ores, because chromate ores are more stable. Hence, so we use aluminum metal over here, so which upon heating to a very high temperature, once again maybe around 1200 degree and plus, so that will give us 2 molecules of chromium along with aluminum oxide. This is nothing but bauxite, which once again becomes the ore for aluminum. Okay. So I hope so you have understood what is hydrogen reduction method, what is reduction of aluminothermite process, and as well as so we discussed about the coke reduction process. So these are all techniques which are used for obtaining the crude or impure metal for that. So now we will be talking about summary of the class. So I will be doing the next part in the next future classes. So the summary what we discussed is the occurrence of elements, then we discussed about the concentration of ore. In the next classes I will be talking about how the isolation of metal is done. Okay. So from which methods, that is reduction as well as the refining of metals will be done. Okay. So now after my class, so I request you all of you to log into the CPP, that is class practice session. Okay. Class practice session. So immediately answer the 10 most important question based on the today's topic we have selected. I hope so. Thank you for joining us. All the best.